All right, I don't know why this video cannot be played anymore, but okay, no worries. Just listen to me, and I will introduce to you. So if we want to learn the programming of CR robots, the adjusting motion speed of the robots will be what you'll need, and the use of simple motion instruction of CR, the use of program flow control instructions, and the operation of our interface, and all by the analysis of the PDP motion cases. Okay, so in the part of PDP motion, we have different tests for our training. First one would be to creating the program. Then we need to optimize the running speed of the program. And third one is we learn to use the motion commands. And the fourth one would be to control the program flow. The fifth one would be I/O monitoring, the interface operation. We will introduce you them one by one. Okay, the use of the program with the CR robot is quite straightforward, and here's it. So the programming flow is quite easy. We just start with the latest software we call the Dobot Studio Pro. Create a project, start project. Then we teach the points. We can use the hand guide function to guide the robot to reach somewhere. And if the points you need it very accurate, you can move the robot with your hand, and then you can control the robot with the panels. With the panels in here, in the control panels, to do it, to do a more accurate move with the buttons. All right, with the handhold, we can guide the robot with the big moves, and then for the manual fiction, we can use the buttons. And then with the points ready, we can write the program, and then we can call the points in our program, and then we can debug the program, check if there's anything wrong. If there's not anything wrong, we can run the program. Okay. So usually for a project of CR robots, it usually consists of 3 different parts. The first one would be the saved points information, which is the coordinates information of the different points. This is the first one. And the second one would be the global variables. If you are using the variables, it's necessary to check before you run the program. And the last one would be the scraps or the blockly project files. So you can see that we are dividing the SRC into different threads. The first one is called SRC0. It's the first thread. We can run at most 5 of them, from starting SRC0 to SRC4. So there are 5 threads in total. But be advised that all the motion commands must be in thread 1. Motion must be included in SRC1. So for the others, you can put it into the other threads, but for motion commands, you have to write it in thread 1. Okay, so let's continue. So for the motions, there will be different commands and different parameters. So first, I'm going to introduce the parameters here. The first one would be speed, or speed S. This is the speed linear speed with a proportion motion speed value range from 1 to 100. The bigger the number is, the higher the speed is. The second one would be the accelerators or acceler. This is the acceleration speed. Sorry. The value starts also from 1 to 100. The higher the value is, the higher the acceleration is. The last one would be the CP smooth transition. What is CP? CP is the smooth transition during the motion. The range is from 0 to 100. There will be picture on the afterwards, and I can show you about the difference between. I can show you the function of the CP as well. So there are some notes that you need to be noted, that if you don't set up the parameters for the speed S, acceleration S, if they are not set in the program, the default value is 50, which is the middle of the level. Users can increase the bit by setting up the parameters to increase to reduce the cycle time of your project. You can increase the speed as well. And what are the difference for speed and speed S, accelerator and accelerator S? So the difference is that speed and accelerator are suitable for go, move G, go R, move JR, and speed S and accelerator S are suitable for move, jump, arc 3, circle 3, move R for the different commands. So actually they are of the same function, but just for different different commands. You can choose the corresponding one to your commands. Okay, so you can here see this picture is. I think I can put it larger. Okay, so you can see from here we are putting these different meters in here. Before the forever block is joint speed ratio 100, joint acceleration 100, continuous path ratio 100. This is the CP. CP is short for continuous path. This is the CP, and this is the CP ratio 100. Okay. Let's continue. So a little more introduction for the acceleration. The acceleration of the speed. That means if the acceleration is higher, the change of the speed is much faster. And jerk it means it's actually the changing speed of acceleration. You can regard it as the acceleration of acceleration. So it's a little tricky, but it's that meaning. All right. So the higher the jerk is, the faster the acceleration changes, and the higher the acceleration is, the higher the speed changes. So we can go to the settings for the different jog settings and change the different accelerations there. But please don't change it to a very large bit. If you have any problems, means the changing of the parameters, you can come to us and ask for support. We will provide you with advice there. And the motion speed of the robot is the combination of joint speed, global speed, joint speed, and speed in the parameter, and with the global rate. So you can see if the program runs slow, you should change from 3 different aspects. First one would be the joint speed, then the whole speed in the script, and the global rate. Global rate is what we put in here. This is the global speed. Okay, we can choose a different global speed during the whole progress. So you can see when running, if the motion speed is lower than preset, it's mainly due to the running distance of the machine, and speed does not reach to the set speed. So users can increase the speed by adjusting the speed and acceleration. It's not recommended to modify the speed parameters. So if you have any requirements that you want to increase the speed, try with this one. Try with this speed in the joints, like we mentioned here. The accelerations, the speeds, something like that. But usually we don't encourage our users to change these parameters by themselves. It will cause problems sometimes. If you need to change, if the the speed or the global rate, this is also you can do. This is what you can do, and this is what you can do. But if you want to change this, you can contact us first, and we will provide you with some suggestions for you. Okay. All right. These are the motion commands. We can see that this is the difference between the moj or go and move commands. You can see the biggest difference is that the trajectory. The trajectory for moj and go would be a curved line. The robot will go from A to B in a curved line, which is suitable, which the algorithm thinks is most suitable for the robot. But with move command, it just go from A to B in a straight line. So if your application requires the robots to go in a straight line, use the move command. But for others, you are recommended to use the move J and go. You can choose the different ones according to different applications. So below here is some examples for the use of the commands. This is the go command, and this is the parameter steer. We put 100 speed, 100 acceleration, and CPU 100. And this is moj. Moj means the move of the joints. And here also move. This is speed 100, accelerate CPU 100 as well. So we can say we can combine the different commands with different parameters in there. And now this is what I'm talking about for the CP. You can see the difference between those two different scripts. The biggest difference, the only difference is that the first one comes with a CP 100 and the second one doesn't. So what's the difference? Those pictures are the trajectory of the robot moving from P1 to P3. P1, P2, P3. And this one same, P1, P2, P3. You can see that we use these commands, the robot moves starts from P1, directly P2, then go to P3 directly. But with this one, you can see that the robot, in reality, the robot does not reach to P2. It just come close to P2, but it will not reach to P2. So this is what the CP do. This CP will provide you smooth transition from one point to another. So in a sentence like this, if we start from P1 and the final point is P3, and when you CP 100, the robot will move close to P2, approaching to it, but it will not really reach to P2. So you can see from the picture to know the use of CP. With the CP commands, we can smooth the motions of the robots. So which will make the robots move in a smoother way, and it's more fast. Okay. Wait a moment here. Sorry, we will continue. So this is the function of CP. So if you don't want the robot to go too smoothly, you can decrease the value a little bit. You don't have to put 100 in there. Okay. So after running the script, the yellow cursor on the host computer indicates the script runs, but this function is not async. Okay, I think I will just skip these parts because, okay. you can we all know that there will be two different progress in the your run program. Is that the running of the scripts and the running of the robots. So most of the time, the running of the robot and the running of the scripts are not at the same time, which means in our previous controlling software, which is called Dobot SS Studio, there will be a yellow cursor on the host computer, index the script runs, and the yellow cursor index the robot runs. You can see that if you used our SS Studio, you will see that the two different cursors are not running at the same time. In most cases, the two are out of sync. So usually the script will run ahead of the robot for most cases. For example, if we use this scripts, the move P1 first move to the grabbing position, DO1 turn on to collapse the object, wait 100 milliseconds, hold still for 100 milliseconds, and then move P2 and left, and we do detect if the robot is if the object is in position. So after this script running, you will find the returning value is always 0. Why is this? This is because when you run this script, this value will be returned immediately after the script is running, before the robot can take the object to the distance P2. So when the value is returned, the robot itself is not reaching to D2. It's on the way, but it's not reaching there. Okay. So how do we prevent this kind of situation from happening? This is why this is the reason. The reason of this question is the two running is not in the sync, which means the script and the robot itself is not running in the same time. So how do we stop this? So we are using this sync in here. Sync. We are using this function, which means we need to wait until those commands are finished together, and then we return the value at the end. So with this function, the script waits for the robot to reach to P2 and then returns the value of DI1. So in this way, there will be the right value returning after the robot moves to P2. Okay, so this is the usage of sync. All right. And wait. We put the wait and sleep in the same page because some of our users are often confused when they use two different commands, which they look very familiar. So what's the difference between wait and sleep? Wait is actually the delay of the algorithm queue. Executing wait will move a delayed command into the algorithm execution queue. It's generally used to delay the motion and I/O operations. So we can see that wait is more likely to use on the moments of the robots. For example, in this one, move P2, move to the grabbing position, and DO1 to grab the robot. Wait 100. It means hold. Hold means the moment. We hold the moment for 100 milliseconds, and then we do the next move. So wait is actually for the movement. And sleep is the interval between two commands, but the running interval cannot be guaranteed. It's generally used to delay the programming. So you can see that sleep is more likely to use for scripts. So we can use the sleep for different scripts. We run the scripts from mo to do we can use wait, we can use sleep, we can use sleep in here to put the interruption between the two commands. So this is what we use with the wait and sleep. So you can just remember the features that wait is for movement, sleep is for script. So that's the biggest difference. Okay, so for the programming language, it goes with VCR is Lua, which is fully supports Lua native functions, APIs, multi-threading, and other mechanisms. I'm not going to introduce a lot of Lua in here, but you can check more details in this page here. So yeah, just I'm going to introduce you a little main features of the Lua looping here. So we have this while loop, for loop, repeat until loop, different kinds of loop types. So for different conditions, for while loop, when the precondition is true, the program will be told to execute some statements repeatedly. So checks whether the condition is true before executing the statement. This is what the while loop do. And for loop executes the specified statements repeatedly. The number of repetitions can be adjusted in the for loop commands. And repeat until means repeat the loop until specified condition is true. So this is the difference between the different loops. I believe this is universal for different kinds of programming language. So this is very universal. Yeah. And how do we to jump out of the loop? We can use break statements to exit the current loop or statement and start to execute the following scripts. And here's the if statement. If statement consists of a Boolean expression as a conditional judgment, followed by other statements. And also we have the if-else statement. If statement can go the else statement to execute the else statement command, while if condition operation is false. So if it's true, just go to condition 1. If it's not, if it's false, go to the next one. Okay. If next statement, we can use one or more if-else statements using one if and if-else statements. Okay. And here, I'm going to introduce you about I/O status and DO signal manually through the DO monitor interface. This is the I/O monitor in the software of our Dobot Studio Pro. Okay, as most of our users are here and like to introduce about our Dobot Studio Pro. Some of our old users might be familiar with Dobot SC Studio. But now we are no longer we are encouraging our users to converting the programming software to Dobot Studio Pro. This is our latest software, and there will be a lot of new functions on this software. So if you have no problem changing your projects, you can totally try this Dobot Studio Pro with your project. But in some running projects that are already finished, you can use your current software as well. The DO signal, the DI signal can also be simulated during the program debugging. So usually we can use this panel to test. So we can use this one, for example, while true do, if DI1 is on, then move, else print hello world, and then sleep 100. So this program can be executed by simulating DI signal. You can actually try this program on your own if you have robots around you, and this training material will be sent to you later. Another thing that about the collision detection function, this is included in almost in all our CR robots. So as I mentioned before, the safe skin is optional. You can choose one CR robot with or without safe skin. Of course, the price will be different, but this one is in default that is available for every CR robots. So we can choose to change the level of the collision detection. If this function is turned on, the robot will immediately stop when it runs into an obstacle to avoid dangerous collision. So we have we have 5 different levels of the collision detection. The higher the level is, the higher the sensitive is. For example, if we use the level 1, it might be punch the robot for once and the robot will stop. But with level 5, the robot might slightly touches you and it stops. So the higher the level is, the less force will be triggered the collision detection function. So, but for some other applications that you don't, there's no one working around the robot and you don't want the robot to run in the collaborative mode, you can also disable this function. They have this button here. You can also disable it to reach a higher working speed. But usually it's open in default, and we suggest our users to keep this function on. All right. Okay, this is the second part of the stacking transporting. There should be a video here, but I'm not afraid that the video cannot be played. I'm not sure. Oh, it's okay.